Hi, this is Mrs. Bricky, and this is Math 1050, Section 4.5, working with exponential and logarithmic equations. In Section 4.5, there are 5 topics, but I'm going to put that last topic with 4.6 instead because it, to me, goes with 4.6 better than it goes with this section. Okay, so the first topic is solving log equations, and the way that we're going to solve these is by converting them into their equivalent exponential form. So our first equation is log base 64 of x is equal to 1/2. Well, remember that if we have a log of x equal to y, it's the same as b to the power y equals x. So our base is 64. That's going to be the base of our exponential. The thing that the log is equal to is the power. So this is going to be 64 to the 1/2 power, and it's equal to the argument of the log. So in this case, the argument of the log is x. So we get 64 to the 1/2 power. You can evaluate that in your calculator, or maybe you remember that a 1/2 power is the same as a square root. So this is going to be 8 as our solution. Okay, in this next equation, we again have a log equation. If we convert this into exponential form, it's a little bit different though, because our base this time is our variable x. So if we write this log in exponential form, our base is x, and the power is 5, and it's equal to 32. So we're solving the equation x to the power 5 is equal to 32. There's several ways you could solve this. To undo a power of 5, you might remember that you can use a root. So you could do the 5th root of both sides of your equation. Or it's possible, if you don't remember that the way to undo a 5th power is a 5th root, you could also think of it as that you're raising both sides to the 1/5 power. That would leave the x with a power of 1 here. So in your calculator, you can either type in the 5th root of 32 or 32 to the 1/5. And I have my calculator, so I'll show you that those two are the same. So we could do the 5th root of 32. And make sure you actually do use that other index for the root button there. You should see the 5 tucked up small when you type it in. Or you could do 32 to the power 1/5 to get that same answer. Or maybe you're just like, I know that 2 to the power 5 is 32. Any of those ways will work. And so we get our answer x equals 2. Okay, the next topic is to use the properties of logs to evaluate each expression. So I've got several expressions here. One of them is a natural log, the other is a log base 14. So we're going to use our log properties. So I have that property list from your reference sheet over on the right-hand side. For this problem, we're first going to use the power property, which is property number 5. And that is that if we have power of our argument, we can bring it down into the front as a coefficient. So we're going to use that property first. So if I bring this power of 5 down and I bring this power of 6 down, that is going to give me 5 times the natural log of e minus, now if I bring this 6 down, there's already a coefficient of 2. Those would multiply together. That's a 2 times 6. So that's going to be 12 natural log of e. Okay, now we're going to apply this property right here. Remember that natural log is just a log with a base of e. So we can apply this property that the log of any base of that same number is equal to 1. Well, this is log base e of e, so that's the same as 1. So this is 5 times 1, which is, of course, just 5. And then again, this quantity, natural log of e, is 1. So this is 12 times 1, So 5 minus 12 gives us the solution -7. Okay, for the second one, we have two logs that are being added together. So we are going to use this product property of logs. If we have two logs with the same base that are being added together, we can multiply their arguments in a single log. So if I multiply those two arguments together, this is the same as log base 14 of, well, 2 times 7 is 14. So this is log base 14 of 14. And again, applying that same rule that we used for the first problem, log base 14 of 14 is equal to 1. Okay, our next topic involves solving a multi-step equation with natural logs. So I have two examples here that we're going to look through. So this first equation is 2 times the natural log of x minus 3 is equal to -2. So the first thing we need to do in this equation, and with any log equation, if we have a coefficient, we want to divide that on both sides, of course. And so that leaves us with the equation, the natural log of x minus 3 is equal to -1. And now we are going to use our rewriting skill. So this is natural log is a base e log. So if we rewrite this into exponential form, this is a base e with a power of -1 equal to the argument. And we're really almost finished. We're trying to solve for x, so we just have one last step. We need to add 3 to both sides. So we get e to the -1 plus 3 is equal to x. We can evaluate that in our calculator. E to the power -1 plus 3. So e to the power of -1 plus, plus 3. That's equal to 3.367. This asks me to round to the nearest hundredth. So we will keep 3.37 as our answer. Okay, our second equation has two logs in it. We have the natural log of 5 and we have the natural log of x minus 3. Now, there are at least two ways we could do this, but I'm going to go ahead and start by using my product property of logs. If I have a log added to another log, then we can combine them by multiplying their arguments together. So this is the same as the natural log of the 5 is being multiplied by the x minus 3. And I could distribute that 5, but it's really not necessary to distribute. So I'm going to go ahead and just leave it out like that. Okay, so now remember, this is a natural log, so it's a base e log. So we can rewrite this in exponential form. So it's going to be a base of e with a power of 3, e to the power 3, and that's equal to the argument of the log. So it's equal to 5 times x minus 3. Okay, so again, our goal is to solve for x, so we can just use some simple steps to get that x by itself now. We can divide by 5. So we get e to the third over 5 is equal to x minus 3. And then our last step, of course, would be to add 3 to both sides. And we can, of course, use our calculator to crunch that. So this is e to the third power over 5, and we want to add 3 to that. And so we get the answer 7.017107. Our calculator asks us to round to the nearest hundredth. our problem asks us to round to the nearest hundredth, so we will keep our answer as 7.02. Okay, last topic in this section, solving an exponential equation by using logarithms, and these are definitely advanced problems, a very difficult problem. So what makes this problem difficult is that we have two exponential on each side, a base 17 exponential and a base 3 exponential. And there are definitely several ways you could attack this problem. I'm going to show you the way that makes most sense to me. If you hate this way, I can show you some other ways to solve it. Just let me know in class. So the first thing that we're going to do is we can't really rewrite this into a log form because we have an exponential on each side, or we could write it in log form, but it would be awkward because of the exponential on both sides. So we're going to start by just taking the natural log of both sides. So we're going to take the natural log of 17 to the power 8x, and we're going to take the natural log of 3 to the negative x minus 4 power. So the reason we take the natural logs of both sides is so that we can apply the power rule here and bring these powers down to the front. So our equation looks like 8x times natural log 17, and that's equal to, and because this has two terms, I'm going to throw it in some parentheses so that I can keep that grouped together, natural log of 3. So we brought those powers to the front. Okay, so our goal is to get the x by itself, and right now I have an x in two different locations, and we're going to use a strategy that we've used before when we were finding the inverse of rational functions, or it seems like we've used this strategy a couple of times, but we need to distribute here, and then we are going to collect all of the terms with an x. So let's start by distributing. So my left side is not changing right now. So this is negative x times the natural log of 3 minus 4 times the natural log of 3. And that natural log of 3 is just a number, and this maybe feels a little awkward because it's not something we're very used to, but it's totally fine. All we did was distribute that number natural log of 3. Now, even though it's a number, it is probably customary to keep the x in front of it, more because if we wrote it with the x afterwards, it almost looks like the x is with the 3, and in this case, it is not. So that's one of the reasons that we keep that x in the front of the log, because it's an x multiplied by a natural log, and we don't want to start thinking that x is inside the log. Okay, so you can see that I now have two terms that have an x in it. I have this term over here with an x, and I have this term over here with an x. So I want to collect those together. So I'm actually just going to add that x log 3 to both sides of my equation, so that it cancels out from this side, and I've collected all the x's together. Now I can't really combine these two terms together because one has a natural log 17 and they're just very different. So I'm going to keep them separate for a second. And the only thing I have left over on the right side is this negative 4 natural log of 3. Okay, so now is the key step where I recognize that I've got two terms with an x in them. I'm going to factor out the x. So that x is going to go to the front. In this term, what that leaves behind is an 8 log 17. And then in this term, what it leaves behind is that log 3, natural log 3. Okay, so we are almost there. We just have one last step before we can put it into our calculator, and that is that we need to divide by this quantity so that that x is by itself. So our answer ends up being -4 natural log 3 over 8 natural log 17 plus natural log of 3. So I just divided that 8 log 17 plus log 3 to both sides, leaving the x by itself. And now we are ready to type that into our calculator. And so this is, use my little fraction button, -4 natural log of 3 over 8 natural log 17 plus natural log 3. And I didn't close the parenthesis on the top. That's not going to affect it, but I'll go ahead and do it. All right, so here we get our answer. Oops, negative. And it told us to round to the nearest thousandth, so I need to keep 3 decimals. So negative 0.185 is our answer. Now, for the love, this was a very complicated problem. And if it shows up on a test, especially, or if you don't want to accidentally miss it, check your answer. Like, these are very difficult. Make sure that your answer is the true solution. So what I would do is in my calculator, I would evaluate the right-hand side. And I would evaluate the left-hand side. And see if they're the same. And it's fast enough to do in your calculator, and it is worth it so that you don't miss a test question. So 17 raised to the power 8 times negative 0.185 gives me 0.0151. Okay, and now if I evaluate the other side of the equation, that's 3 to the power negative 0.185, subtract 4. And look at that. I know that it is correct because those two right and left-hand sides are the same. So definitely I would advise you to check your answer. It's worth it. It takes 2 seconds to type that in, and if you have the wrong answer, it gives you a chance to look over your work or start again and try to get it right. All right, that is it for this topic or for this section. Let me know what questions come up. Thank you.